NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
NASA has been celebrating after engineers managed to fix their Voyager 1 probe.
Flight team is so happy to once again have meaningful conversations with Voyager 1.
Outside of our pale blue dot, there are two spaceships that have pioneered groundbreaking discoveries and shed unfailing lights on the world around and beyond our system. The Voyagers have transversed through the whole space of the solar system, venturing into uncharted territories of the great starless void. Today, Voyagers have spotted something incredible that has scientists hitting the alarm button. So what have they uncovered? What is the future of space exploration? Join us as we reveal what Voyager detected at the edge of the solar system that shocks NASA. The beginning of history. It's impossible to talk about the importance of the Voyagers without a look into their origin. In a world that's defined by constant technology advancements and groundbreaking scientific discoveries, NASA set another course that changed our perspective of outer space in 1977. Two golden spacecraft, each about the size of a small bus, were created to take our understanding beyond the limitations of our atmosphere. These twin explorers, named Voyager 1 and Voyager 2, were set to embark on the longest road trip in human history. The excitement at NASA was palpable as engineers and scientists put the final touches on the Voyager spacecraft. Their sleek bodies gleamed with gold, not just for looks, but to protect their delicate instruments from the harsh conditions of space. Voyager 1 and Voyager 2 were outfitted with an array of cameras, spectrometers, and other scientific equipment, all designed to unravel the mysteries of our solar system. The original plan was simple: a quick 5-year dash past Jupiter and Saturn to take pictures and collect data. But these adventurous spacecraft had other ideas. Voyager 2 became the cosmic superstar. After gliding past Jupiter's swirling storms and Saturn's stunning rings, it sailed on to become the first spacecraft to visit the icy giants, Uranus and Neptune. The pictures it sent back left scientists in awe. Uranus's tilted rings in 1986 and Neptune's fierce dark storms in 1989 showed us worlds we had only dreamed about. Voyager 1 was on a mission for an even bigger prize. In August of 2012, this tireless explorer did something no human-made object had ever done before. It broke through the bubble of our solar system and entered interstellar space. Think of it as crossing from your backyard into a vast wilderness that no one has ever explored. Scientists were so amazed that they spent a whole year double-checking their data before announcing this groundbreaking news in 2013. These spacecrafts carried something truly special: the most advanced technology of their time. Each Voyager had more computing power than the early home computers of the 1970s, along with instruments that could measure everything from magnetic fields to tiny particles in space. Most impressively, they were built tough, designed to handle temperatures cold enough to freeze nitrogen and radiation levels that could instantly destroy a smartphone. Their journey has revealed countless surprises. They discovered that Jupiter's moon, Io, has active volcanoes, the first we had ever seen beyond Earth. They spotted unknown rings around Jupiter, found strange spokes in Saturn's rings that shouldn't exist, and measured solar winds that no one even knew were there. These spacecrafts were built when digital watches were cutting-edge technology, when most phones still had rotary dials, and when the internet was just a dream. Yet they're still going strong, still sending back data, and still teaching us new things about our cosmic neighborhood. Today, Voyager 1 leads the way as humanity's farthest-reaching creation, while its twin follows closely behind. Together, they've changed astronomy textbooks, solved ancient space mysteries, and opened our eyes to the true size and beauty of our solar system. They've traveled so far that their radio signals, moving at the speed of light, now take over 22 hours to reach Earth, and they're still on their journey. What began as a modest 5-year mission has turned into humanity's greatest space adventure, a journey of over 45 years that has forever changed how we see our place in the universe. So the puzzle is, how are they able to communicate with Earth while they're so far away? Let's find out. Communication system. Voyager 1's communication system relies on a magnificent dish antenna. Unlike the tiny ones used by home satellite systems, Voyager 1's dish is over a meter wide. Its size gives it sensitivity. Its carefully controlled shape makes it a highly directional antenna. In fact, if the high-gain antenna could be aimed at a target on Earth, it could cover an area approximately half the size of the state of Pennsylvania. The Voyager 1 spacecraft sends messages to Earth using two different radio frequencies, 2.3 GHz and 8.4 GHz. When Voyager 1 receives a message back from Earth, it requires that message to be sent at a slightly lower frequency, 2.1 GHz. These frequencies work extraordinarily well in the vacuum of space. They are fine-tuned to be even better than the good old space radio that the Apollo astronauts used. The signals transmitted by the spacecraft start out as a puny 20-watt emission, the same as a typical light bulb found in a refrigerator. When these signals reach our planet, they have transformed into the most undeserving of waves, far less energetic than a whisper in a quiet room. But NASA's large, 230-foot-wide missiles of dishes are still able to eavesdrop on what is practically nonsense coming from the Voyager spacecraft. To cover the enormous gap, Voyager 1 carries a digital tape recorder that has a capacity of around 67 megabytes. That would be enough to hold about 15 songs on a typical phone. But music can't really help us understand who we are and where we come from, unless you play the kind of music that's on the golden record. Voyager 1's still functioning and still sending back data from over 13 billion miles, making it likely the most remote tape player in existence. It takes over 22 hours for each signal from Voyager 1 to reach Earth, long enough to traverse the world twice. In comparison, the Mars rovers can ping Earth and get a response back in a brisk 15 minutes. Every communication with Voyager 1 is a feat of patience and precise timing, necessary for the kind of simple interactions that keep this farthest from home spacecraft in touch with the people who built it. This cosmic chat relies on NASA's Deep Space Network. The network has within it what might be considered the two best ears in the solar system. These ears are made of antennas. The antennas are of two types. One type is the 230-foot diameter antenna, and the other is the 112-foot diameter antenna. The two types of antennas together are sensitive enough to detect signals 1,000 times weaker than what a person could hear with a local FM radio station. Modern technology has made these detectors so sensitive that they could, in principle, pick up signals from space probes situated many light years away. The big question is whether they could do so if the signals were not somehow boosted to an energy level many times greater than that of the signals we now get from Voyager 1 and 2. Maintaining the link between Voyager 1 and Earth calls for astute control of power. The spacecraft generates its electrical energy with the help of nuclear batteries called radioisotope thermoelectric generators. These power sources lose power with time, but unlike an ordinary battery that eventually gives up the ghost and stops functioning, an RTG just keeps on going until it runs out of usable power, similar to how an ordinary flashlight dims before it gives up. At the time of its launch, Voyager 1 had a power supply of 470 watts, enough to energize 4 incandescent light bulbs to their full glow. Today, even with decreasing sunlight, the spacecraft operates on less than 300 watts. Yet even that figure is misleading, for the heaters that keep some of Voyager's tenuous circuitry in working order use power that, when added to what the working instruments themselves require, comes dangerously close to the 300-watt ceiling. Power management is job one for the command team. Even with these attempts to conserve energy, the supply on Voyager 1 continues to decline at a rate of about 4 watts per year. This steady drop forces the mission's engineers to keep coming up with new ways to boost what's left of the power and, most importantly, to maintain the connection with Earth. With the aid of these advanced communication systems, these pioneers have been able to achieve countless things. The Voyager's achievements. Voyager 1 has kept voyaging ever since its creation, and as of August 2022 is approximately 14.6 billion miles away from our planet. It is currently zipping through space at an astonishing speed of 17 kilometers per second. Once it got into space, Voyager 1 didn't stop. Moving at an unbelievable pace, Voyager 1 serves as our sight and sound in a bizarre region known as interstellar space. Here, in what amounts to a solar system version of a cosmic graveyard, it is sending back data on stuff we never imagined was out there. The still-functioning Voyager 1 is sending back strange data, what the scientists are calling plasma tsunami waves, a curious form of cosmic rays that shouldn't exist, and unexplainable magnetic fields. As Voyager 1 moves farther away from our solar system and the planets within it, we are learning more about what lies beyond our heliosphere, about the very edge of the solar system and the interstellar medium. What surrounds Voyager 1 is not what we anticipated. Rather than being void, it is a mixture of different charged particles left over from stellar explosions that occurred millions of years ago. These particles convey narratives of violent and tumultuous cosmic events that we are only just beginning to comprehend. Voyager 1's most noteworthy find could be the one it made about our solar system. Backtracking from its current position, it is giving us a look at the heliosphere, a colossal bubble formed by the solar wind emitted by our sun. The spacecraft has demonstrated that this bubble is not a perfect sphere, but instead is squished and dented by the pressure of interstellar space. Its surface is an irregular, wavy sheet. It bulges slightly in the direction our solar system is traveling through the galaxy, and it dips down in the direction of the nearest star, Proxima Centauri. Its surface area is enormous, but we are only at one end of it. The next solar system is fairly close to us, but even so, it has 500 million years of history behind it. Even though Voyager 1 has been functioning for an incredibly long time, as long as many of its engineers have been alive, it doesn't show any signs of aging. Every second, it's moving another 17 kilometers into the wild unknown, deeper and deeper into the deep annals of space, and thereby cementing its place in the cosmic human history. Every signal it sends back becomes somehow even more significant, a new milestone in the story of exploring the human frontier. So, have you ever wondered how a machine built in the 1970s is still functioning perfectly in the harshest environment known to humanity? Let's delve into the deep details. An engineering marvel. The Voyagers aren't ordinary spacecraft. They are one of the toughest ever built by humans. A lot of work and thought is put into building something that's supposed to survive the harshest place in the universe. Let's start with power. While most spacecraft use solar panels, Voyager's engineers knew that wouldn't work in the darkness beyond Saturn. Instead, they gave it 3 nuclear batteries called RTGs. These amazing power plants use heat from decaying plutonium to create electricity, the same process that keeps Earth's core hot. Each RTG started with 470 watts of power, about enough to run 4 bright light bulbs. But Voyager 1's true genius shows in how it handles the brutal conditions of deep space. Its outer shell is wrapped in special gold-colored foil that reflects heat and radiation. Inside, it has 3 separate computers that can check each other's work. If one makes a mistake, the others catch it. That's more advanced than many planes flying today. The spacecraft's brain is incredibly efficient. It runs on just 64 kilobytes of memory, less than a single modern digital photo. Yet this tiny computer manages to control 11 different scientific instruments while constantly keeping its antenna pointed at Earth. It's like playing chess, solving math problems, and balancing on one foot, all at the same time. Speaking of instruments, each one is a masterpiece of engineering. The cosmic ray detector can spot single atoms zipping through space. The magnetometer is so sensitive it could detect a refrigerator magnet from a mile away. The plasma sensor measures particles so thin that 1 billion of them would weigh less than a snowflake. The star of the show is Voyager's communication system. Its main antenna, nearly as wide as a tennis court, can catch radio signals so weak they have less energy than a falling snowflake. When these signals reach Earth, they're picked up by massive dishes in NASA's Deep Space Network, including one in California that's taller than a 20-story building. Every part of Voyager 1 was built to last. Its backup systems have backup systems. Its wiring is thick enough to survive micrometeorite hits. Even its computer code is written in a special way that lets it keep working even if parts of its memory fail. The engineers who built it thought of everything, even including spare copies of crucial systems that could be switched on decades later. But perhaps the most impressive thing about Voyager 1's engineering is how it adapts to problems. When its primary thrusters began to wear out after 40 years, it simply switched to backup thrusters that hadn't been used since 1977. Today, Voyager 1 continues its journey, carrying on board the culmination of 1970s human ingenuity. How NASA's Voyager spacecraft avoid black holes and asteroids. Since both of these probes were launched, Voyager 1 and Voyager 2 have traveled through billions of miles of space to study the edges of the solar system and outer regions of the heliosphere. But one of the most mysterious things about their long journey in this vastness of space is the fact that they have not come across disastrous events such as black holes and asteroids. This fantastic accomplishment can be attributed to the brain and hard-working talent of engineers and scientists at NASA. To understand the complexity of this feat, it's essential to consider the vastness of space and the numerous hazards that lurk within it. There are millions of asteroids, comets, and other objects in the universe, and many of them are deadly threats to spacecraft. Also, black holes with strong gravitational force are fascinating and can pull in any object which dares approach. So how did NASA achieve this remarkable feat? The answer lies in detailed preparatory work, accurate calculations, and the use of specific design solutions. As with every launch, NASA scientists have plotted the Voyager spacecraft trajectories in a way that would ensure that they would not run into black holes and asteroids. In light of this knowledge of where the distribution of asteroids was, and based on the known galactic structure, engineers charted a course that would take the spacecraft past less crowded areas of space. Well, gravitational slingshot also assisted with maneuvers, which was instrumental to the Voyager journey. Using Jupiter and Saturn's gravity, the spacecraft flew close to both these planets and flew by at the right angle so that it altered direction and gained velocity from the planet's gravity. Due to this method, NASA scientists were able to determine the gravity pull exerted by these formations and make sure that their craft would not be in an unfavorable orbit. The fact that all these gravitational slingshots were achieved shows the efficiency and workmanship of NASA engineers. Asteroid avoidance was the other component that was central to the mission of the Voyager spacecraft. To reduce this risk, the following measures were used by NASA. Conjunction analysis allowed understanding the approximate asteroid approach and calculating possible collisions. Position control allowed maintaining a suitable distance from the dangerously orbiting asteroid. The specific mode involved real-time monitoring by NASA's Deep Space Network of the Sun, pointed spacecraft position and velocity data, thereby making prompt corrections in the event that one is required. Black holes were even more dangerous to the Voyager spacecraft. In order to identify and evade such space events, NASA used X-ray and gamma-ray monitoring, gravitational wave sensing, and astrometry. X-ray and gamma-ray activities connected with black holes were observed using space telescopes. LIGO and other detectors used to detect gravitational phenomena found that they were produced by merging black holes. The Voyager spacecraft's design features also played a critical role in their survival. Radiation hardening protected electronic components from cosmic radiation, while redundant systems ensured continued operation in case of component failure. High-gain antennas enabled communication with Earth, facilitating real-time navigation adjustments. After over decades of travel, Voyager 1 and Voyager 2 have entered interstellar space, the region outside our solar system. As they venture deeper into the unknown, they face new challenges. The interstellar medium, a tenuous, charged, particle-filled region, poses navigation difficulties. Dark matter, an invisible form of matter, may affect the spacecraft's trajectory. Increased exposure to cosmic radiation also threatens the spacecraft's electronic components. Despite these challenges, the Voyager spacecraft continue to expand our understanding of the cosmos. Their remarkable resilience serves as a testament to human ingenuity and the boundless potential of space exploration. The end is in sight. A part of the journey is the end, and the signs say that the adventure of Voyager 1 is coming to an end after its long journey through space. This incredible probe has covered billions of miles and has pushed the frontier of human exploration further than any other object in history. But now its power is dwindling day by day, desperately clinging on to the last bit that's left of its reserves. When the last of its handful of science instruments goes quiet, there will be no more chatter from Voyager. In 1990, engineers at NASA made the tough call to turn off Voyager 1's camera after it had taken its now iconic pale blue dot picture. In that photo, Earth is a mere speck, a tiny blue dot in the unfathomable darkness of space. It was clear to everyone that the image was historic. Subsequent studies have shown that the Voyager 1 camera might have been able to do a little more, but at this point, there's really nothing left to do with the camera, and it is using an unnecessary amount of power. So the choice became fairly obvious. The last laps of its journey will go like final rounds of a long marathon. From 2025 to 2026, the remaining scientific instruments will gradually stop working. Power levels have dropped too low. They can no longer be kept running. Some instruments might last until the end of this decade, sending their last messages back from the cosmic frontier. The ultimate goodbye might happen in the mid-2030s. Due to a variety of technical factors, the engineers and scientists estimated that 2036 is the most likely year for the Voyager 1 to send back its last transmission. Once Voyager 1 falls silent, its expedition will not have reached an end. The probe will press on through the Milky Way. In approximately 40,000 years, it will swing past a star in Ursa Minor, a star named AC plus 79,388, which is about 1.6 light-years from the spacecraft's current location. Voyager's power supply will continue to light up the golden record for another 5 billion years or so. Long after it has stopped communicating with Earth, the spacecraft will still be sending out a signal that can be detected with today's radio telescopes. Prior to the cessation of communication, scientists aspire to painstakingly collate vital data regarding the solar boundary, the region where our suns reach peters out and interstellar space begins. With the Voyager 1 nothing more than a fading force, what's then is left of the Voyager 2? Let's delve into that. The Voyager 2 voyages on. Voyager 2 is now the second farthest human-made object from Earth. Its mission has afforded us some of the outer solar system's most spectacular sights and a wealth of data about the sun's most distant planets and their moons. Most of that data and many of those images came in a series of remarkable close-up flybys of outer planets, with the spacecraft still sending back information from its last close-up of Neptune in 1998. Yet a simple command to an onboard computer to switch to an auxiliary power system signals a problem that a team working with the spacecraft never anticipated. At the end of 2023, a minor operational error occurred which moved Voyager 2's antenna by 2 degrees. Although this is a small change in human terms, in the vastness of space, it is more than enough to sever the link between the spacecraft and Earth. For weeks now, NASA's powerful tracking system in the Deep Space Network has failed to hear signals from Voyager 2. Despite the impressive tech and antenna arrays of the Deep Space Network, particularly a massive 70-meter-wide dish in Canberra, Australia, the spacecraft is talking to no one. Like a loyal informant, Voyager 2 has been relaying information from the region beyond our solar system. It has been measuring cosmic rays, magnetic fields, and solar winds, phenomena that, when understood, will illuminate the structure and behavior of the universe. On October 9, however, a serious problem developed with the spacecraft's communication system. When hope is dim, one looks for any sign that conditions might improve. NASA engineers are reasonably assured that Voyager 2 has not succumbed to being lost. The deep spacecraft, still operational after a very long time, was hoped to still be working before it set an expected reset. There are a lot of things attached to the Voyagers that's beyond their journeys in space. Plenty of these space explorations have given us invaluable insights into the remote outer solar system, heliosphere, and the star-filled world of interstellar space. They have discovered some facts about the solar wind, cosmic rays, and the magnetic fields that define our cosmic neighborhood. The Voyagers have achieved incredible feats, sailing billions of miles across space while navigating their ways around the immense black holes, while also avoiding hurtling into huge asteroids. These legendary vessels continue to shape our understanding of the cosmos. By carefully analyzing the paths of these pioneers, new designing features can be created to continue their impressive legacy. Launched nearly 5 decades ago, the Voyager 1 and Voyager 2 continue to hover in the space between stars after crossing the heliopause and shedding light on how our solar system works. When these experimental space vehicles finally end their incredible missions, people will look back with fondness and also look forward to the future development of space travel with great expectations. So, as we bid farewell to the Voyager's era, what innovative technologies and missions are poised to take space exploration to a new height? Let's find out. A golden legacy and the next phase in space. As the Voyagers drift into interstellar space, they carry a golden record containing information about humanity, our planet, and our place in the universe. This symbolic gesture serves as a message to potential extraterrestrial life, showcasing humanity's curiosity and drive for exploration. The Golden Record's contents, carefully curated by Carl Sagan and his team, represent a snapshot of human culture and achievement. As the Voyager spacecraft move into interstellar space, the records they carry with them contain information about humans, Earth, and our relation to the rest of the cosmos. This symbolic act is a message to the extraterrestrial life out there that human beings are explorative beings that are not confined to their universe. This will also serve as humanity's message to the universe that it's open to potential collaboration with other life forms all over the universe. In the fictitious message of the Golden Record, Sagan and his collaborating team have provided the extraterrestrial audience with a snapshot of human culture and achievements. For the next step in space exploration beyond our solar system, NASA has created new missions and technologies they would use. The Interstellar probe, a proposed mission, aims to venture deeper into interstellar space, is proposed to be launched in the late 2020s. Other burgeoning missions include the New Horizons that have passed by Pluto and is now navigating through the Kuiper Belt region, proving that NASA is not idle. The next generation of spacecraft will benefit from more effectiveness after great improvements in the development of space technology. Long-lasting missions will be made possible by the advanced nuclear power, radioisotope thermoelectric generators, commonly known as RTGs. The development of new propulsion systems that include fusion-propelled and light sails in particular are likely to change the face of space travel. Another aspect that will bring additional edge is the next-level autonomous decision-making for spacecraft. Artificial intelligence will be fully implemented on spacecraft so that it can work independently, while multiple small spacecraft can collaborate with each other through swarm robotics. The private space sector can no longer be counted as a minor participant in the space exploitation process. The industry has some of the biggest players such as SpaceX, Blue Origin, among many others that are currently designing better stations, optimizing the reusability and productivity of the spacecraft. Cross-border cooperation will also define further developments of space research and exploration projects such as ESA's JUICE, Jupiter Icy Moons Explorer, or NASA's Artemis mission will play a crucial role in the next phase. Looking forward, it's undeniable that the Voyager's legacy will remain the perfect example that will inspire the generations of space travelers, researchers, and engineers. As other long-term missions are set in place, the advancements in technology and collaboration between top nations across the world will have a crucial role in the next phase of space exploration. Whatever happens, the possibilities will always remain endless. Thank you for watching. Make sure to like, comment, and subscribe to the channel. Also check out another interesting video by clicking on the video shown on your screen. See you on the other side.